Hi everyone, I'm Jim Wood from Rainwater Equipment and Rain Harvesting Supplies, and I am here today on behalf of the American Rainwater Catchment Systems Association, also known as ARCSA. ARCSA is a national organization that's made up of a lot of different people from different backgrounds that do lots of different things in the rainwater harvesting industry, from installations to equipment supply, education. So many different people with different talents come together in this organization and share ideas. Here's an example of that. This is the ARCSA manual, Rainwater Harvesting Manual, that was put together. It's a nice resource and it's filled with great content. It's a very thick document. It should be available on ARCSA's website, arcsa.org. I will be covering Chapter 6 of this manual today in a series of short videos to just show you what a dry rainwater catchment system would look like. As compared to a wet rainwater harvesting collection system, the wet system is set up in such a way that the gutters typically feed PVC pipe, which holds water, sends it into a conveyance piping underground, and that water is stored and sent to a collection tank, either above or below ground. There's lots of different ways that you can set up a system. This manual will help you decide what's best for you. Conversely, a dry system is one that is set up to where you're catching off of a roof surface, and the water will make its way into the gutters, into the downspouts, and directly into a water storage tank without actually standing in the piping underground. So I hope you'll stay with me. We're going to spend about 20 minutes here going through a series of short videos on the different components of a dry rainwater harvesting system, and we'll have further videos to come. So thanks for watching. Hi guys, I'm Jim from Rainwater Equipment and Rain Harvesting Supplies, and I thought I'd take some time today to talk with you a little bit about an active rainwater harvesting system. Here in our warehouse in the Dallas-Fort Worth area, we have a 9,000 square foot building that we catch rainwater off of. This building has a metal roof, and it has multiple downspouts all around the building, predominantly at either end. So at this end and the other end of this structure is where the majority of the water runs off. As you probably know, for those of you who've gotten into rainwater harvesting recently or have been in for a while, you can catch about 620 gallons of water in a 1-inch rain per 1,000 square foot of roof structure. Now, what a lot of customers don't realize, or hobbyists or people even getting involved in rainwater harvesting don't understand, is that just because you have a structure that's 1,000 square foot, it doesn't mean you're catching 620 gallons of water in a 1-inch rain unless you catch the entire structure. So what folks will sometimes do is have a downspout or two that they catch off of, and they'll have what's referred to as a dry system. So a dry system is whenever water is caught from the roof, goes into your downspout, and then makes its way into the top of a water storage tank like the one behind me. So you'll see in this particular setup, this building has 3 4-inch PVC pipe that are coming down from the building from one end and have elbows going over to and then down into 90-degree elbows into the water tank. In most cases, customers will put a storage tank on the outside of the building, but in this case, we thought for demonstration purposes and because it was nice and convenient and you could stay out of the weather, it'd be great to have one on the inside. So this is a dry rainwater collection system, as it were. And you can hear right now we're getting rain. So you can hear the water actually going into the top of that tank. So clearly whenever you get a downpour, this water tank will fill very quickly. As it stands, the rain has kind of started and stopped a bit, but it's been raining off and on for a couple of days. So this level gauge that you see here gives us an indication of how much water we're collecting, which is always exciting for those of us in the rainwater harvesting business or hobbyists. When you see that, wow, you're actually catching something that comes from the sky and you're able to use that water for for irrigation, for using in your home after being treated, of course. It's really exciting. And so talk a little bit about what we have here on display. This is a 3,000 gallon polyethylene water storage tank. It's actually equipped with a filter basket with a stainless steel mesh that's 20-inch in diameter and what's referred to as a light guard, light keeping the sunlight out. And I'll show you an example of what that looks like momentarily. But it allows the water to go through and enter the tank without having the debris that's on the roof, which in this case is predominantly leaves and seeds, ending up in your storage tank. When the water makes its way into the tank, as we follow the flow, there are filters that can help keep your water as clean as possible. In many instances, customers will use a fine mesh gutter screen that will prevent debris that's in the water from actually entering the water tank. And if that's being used in a particular system, you don't necessarily need to have a filter basket on top of the tank, because a fine mesh gutter screen will keep that water clean as it enters. When the water goes into the tank, in this instance, we have what's called a floating suction filter or floating intake filter inside the tank. And stand by while we show you what that looks like. As I mentioned in a previous video, floating intake or floating suction filters are a great way to prevent debris from ending up in your pump. And the way that these work, they have a stainless steel mesh filter that is attached to a hose. And the hose can be whatever length you like. A common length is 10 feet. But if you have a short tank, that may be too long. They have stainless steel hardware generally, with a floating ball on the end. And then on the other end of the tank is a threaded nipple that will connect to whatever size bulkhead fitting you have on the side of the tank. In this case, it's 2-inch. So this has to be installed inside the water tank. The best way to do this is to obviously put it on before you put water in. It's a bad idea to wait and try and do it after, unless you absolutely have to, because then you have to deal with water and temperatures, and it's kind of difficult to climb in and out of a tank that's standing upright like this one. So the best way really to do it is to tip your tank on the side, crawl in, and take this end and screw it into the bulkhead fitting on the inside of the tank. If you have a 1-inch or an 1.5 inch, we actually do offer floating filters that are for that size. But these floating filters need to be sized based on the gallons per minute that your pump is putting out. So you don't want to take, for example, a pump that typically does 15 to 20 gallons per minute and choke it down with a 1-inch floating filter, because they're really not suited for that. It will restrict your flow. You really want to use a 2-inch in that particular scenario. But again, these come in 1-inch, 1.5 inch for medium flow rates, and then 2-inch for larger flow rates. You can actually even get them in 2-inch with larger holes for a high flow type floating filter. The purpose is for the filter itself to actually float just below the surface of the water level. So in this case, my YakTech level gauge here, the levitator, is showing me that I have this much water in the tank. So whenever this is installed, the filter will float at this point. The cleanest part of the water is just below the surface. You've got debris probably floating on top, and you've definitely got sediment in the bottom of your tank. So whenever you're accessing the water, it always will pull through the floating filter stainless steel mesh, and you'll get cleaner water if you do that. Hey guys, I want to continue our discussion on pre-tank filtration. And in this particular example, we have a 3,000 gallon tank that has water coming in from the top. Anytime you're catching rainwater, you want to pre-filter the water before it goes into the tank. You can do that at the gutter, you can do it at the downspout, but you definitely also want to consider doing that at the point of entry there at the manway on the top of the tank. Now, the most common size for an opening on the top of the tank is 16-inch. And what you'll find is that you can typically get something like this, which is a 16-inch filter basket. It has a stainless steel mesh screen, and you'll notice there's a lip here on the basket itself. This actually has to be trimmed off of the basket in order for it to sit flush down inside the mounting ring on most of the water tanks that you may see out there or that you've purchased. This one has, again, stainless steel mesh in the bottom only. It comes in a 16-inch version and in a 12-inch version. I think they even make an 8-inch version. And then if you want to get the high flow version of the same type of basket, then we have this option. Same design, except this one has stainless steel mesh on the sides also, which can take on more water. There's not that much price difference, so if you fancy the high flow version of that, that's probably a good idea. Again, though, you would have to cut down the lip if you're just using the basket inside one of those mounting rings. Now, if you decide you want to get a light guard with it, which is a great idea, the light guard keeps the sunlight out of the tank. It allows the water to go through. You can probably see where these openings are in the bottom of the light guard. Water can fall through the basket, preventing the debris to go down into the, fall through the light guard. And of course, it prevents the leaves and seed pods and things of that nature from getting into the light guard. It prevents the sunlight from coming in, but allows the water then to come in through these grooves down on the bottom and go into your water tank. These are great because you don't actually have to trim these down for a 16-inch opening. If you use this assembly, you just set it right in the top of the tank. Of course, you have to remove the lid that comes with the tank to make that happen. Then whenever there's a rain event, and you know that you've captured some water, you're most likely going to have some debris in there. You want to walk up to your tank, dump this off. Of course, if you got a tall tank like this, you may need a ladder. Dump this out and get ready for the next rain event. There have been a number of times where with this particular tank, I have allowed leaves to build up in here and have forgotten to dump it prior to the rain coming, and that can prevent you from catching as much water as you would like. This comes in a 16-inch version, also in a 20-inch version, and if you have a lid that's actually larger than 20 inches, then you may have to get creative. You may actually have to cut a hole in the center of your lid and then take some stainless steel self-tapping screws and put them into this basket and light guard and attach it to your lid, and then screw the entire assembly onto the tank. And that's a great way to kind of retrofit a water storage tank that has a larger lid opening with the tank filter basket and light guard. And that's it for this video. So in this particular system, we actually have a ball valve attached to the bottom of the tank here. Most poly tanks or other water tanks will come with some way to get the water out of the tank itself. This one has a bulkhead fitting that's 2-inch in size. It's got female threads on it, and the bulkhead fitting has a gasket on the inside that keeps the water from leaking out, and it sandwiches the seal on the inside of the tank. So when you've got a fitting on the inside and on the outside, and they come together, and there's a gasket in there that keeps it from leaking. 2-inch threads on this particular setup. The ball valve allows you to open and close the flow of water. It's currently open. I have now closed it with a quick flip of a lever. I'm going to reopen it, which will allow the water then to make its way through this hose and into this pump. Now, this particular pump has to have flooded suction, typically. Although this one also offers a suction lift feature, which allows it to bring water from below the level of the pump and move it up to, say, 26 feet, I think is its max. But most pumps that are centrifugal, that sit above ground, need the water to flood the chamber of the pump before they'll actually run. You don't want to run a pump when there's no water in it for any length of time, or it will dry run and potentially damage the parts on the inside. So this particular pump is what's called a variable frequency drive, also sometimes referred to as VFD, and it will actually spin the motor up to meet the demand of the water usage and reduce the motor speed as needed, which is a really nice feature. Typically a VFD type pump will cost in the $2,000 to $3,000 range. Some of them are less expensive in the $950 range, but it typically depends on the manufacturer and whether the parts are made out of stainless steel on the inside or of plastic. So you'll see in this case I have an inlet, and the inlet on this one has a filter screen inside of an irrigation filter, also called a Y strainer. If I were to open this, which I can't do now because there's water in it, there's a filter screen on the inside that also keeps fine debris from entering the pump. It can be opened and removed periodically and cleaned and reinstalled. And you'll see that have these ball valves open. You can always tell that the valves are open because of the way that the handles are turned. That's closed. That's open. So we're going to demonstrate this pump now. This is the DAB EasyBox Mini 3. It's 3 stands for the number of impellers that the pump has inside. So this is again a VFD pump. I'm going to demonstrate how it works. It's very quiet. It's currently unplugged, but I'm going to plug it in right now and just kind of show you what to expect. A pump like this, it will predominantly stay plugged in all the time when it's being used. And when there's a demand for water, like you've opened the ball valve here, it'll turn on. And there it goes. You can see it's currently running. It's currently set at 48 psi at the discharge, which is nice pressure. This pump is adjustable by holding these 2 buttons in for a few seconds. You can then reduce or increase the psi and then hit set to your desired pressure. So this pump will run until I turn off the valve. So we'll simulate someone in the house turning off the shower or turning off the sink. It's building pressure up to 60 psi and stops. So it will stay in this state until someone opens a valve again. Now, you can see it's completely off at this point. So I've got someone in the house now that's just opened a sink. And then somebody steps into the shower. And now it's going full blast again. And it will meet that demand as this pump is in use. If there's multiple shower heads going or a washing machine and things turn on and off, it speeds that motor up and down. So we're going to walk around here. I'm going to show you what we're doing currently. We've got this hooked up to a garden hose. Since this is a dry system, we have another water tank, if you'll come with me. And we're using this water hose and this pump to refill manually. So this is one of the drawbacks of a dry system, and that is that if you have multiple water tanks like we do in this instance, you know, we're catching water. You can see it's still raining. I'm catching water in a dry system here with this particular tank as well. Then you have to pump water from one location to another, because this is our main tank that actually feeds the complex here with water. So this water that comes out of this tank is actually being treated and is safe to drink. The one in the other portion of the building on the inside is not being treated until it gets transferred to this tank. So again, demonstrating a dry system versus a wet system, which we'll come to later. So I'm going to climb up the ladder here, open the access hatch, and just show you that we're getting a significant amount of pressure coming out of this water hose. In fact, this tank is almost full. You can see from the outside here we have another one of these level gauges that shows you the actual level of this tank. So now I'm on the inside of the building again, and right outside of this wall is the 5,000 gallon metal tank that we saw, and this pipe coming in right here is the one that comes in from the water tank. So it's got a check valve right here installed, and then piping that goes into the suction side of this VFD pump. This is a Grundfos pump, and this one has all stainless steel internal wetted parts. So it's a little higher end than the one we saw a while ago. This pump is set up so that it can actually push well water or rainwater. The green handles on the piping here indicate this is my rainwater that's coming in from the water tank. The blue handle over here is my well water. Now I've currently got the well water turned off and have had it turned off for about a year. The green handles are open because we've been using rainwater at this location successfully without having to switch back over to the well, because we're catching enough water off of this structure to be able to do so. In many cases, you may not have a large enough structure at your location in order to survive on rainwater alone, and you have to switch back and forth. So the water is then pushed out of this discharge, up through this pressure valve, actually through this piping, which the pressure valve is attached to, and through this UV filtration system. So the gauges are installed on either side of the unit to kind of keep an eye on your inbound pressure and your outbound pressure. The first housing that you'll see here actually has a sediment cartridge on the inside. It's a 4.5 by 20 inch sediment cartridge, as they're commonly referred to as. And people often ask, how often do these cartridges need to be changed? Well, it's difficult to say because it depends on how clean or dirty your water is. The second cartridge is a carbon filter, and it tends to restrict the flow more so than the other filter does. So when you notice a drop in pressure on the discharge side of your UV system or your filtration system, it's typically the culprit is this carbon filter that needs to be changed. You notice that I've got about 50 psi coming in and going out. These have been in place, like I said, for about a year. I'm surprised that we haven't seen a drop in pressure yet on this this gauge, but people typically will replace their cartridges at least once a year, and their lamp that goes on the inside of this stainless steel chamber, which was the next thing we need to talk about. So as the water goes through this sediment filter, this carbon block filter, to remove any odd taste or smells in this cartridge, then it'll enter this stainless steel reaction chamber. Inside of this chamber is a quartz sleeve. I don't know if I have a quartz sleeve here, but I definitely have a lamp. Inside the chamber is a glass tube, and referred to as a quartz sleeve. The lamp will actually slide down inside of that, and as the water passes over it, this is of course lit up with ultraviolet light. Then it deactivates bacteria that's present in the water, and then from that point, after it exits that chamber, the water is then at this tap effectively safe to drink, or potable, as you'll often hear it referred to as. Excuse me. These ball valves that are installed on the inlet and outlet side of the UV system are so that you can shut the valves and close the pressurized water when it's time for you to do maintenance or replace your cartridges in the filter housings or replace your lamp. You certainly don't want to try to do that without closing the pressure off. And these buttons that are on top are called pressure relief buttons. Once you've closed your valves and it's time to then release the pressure, you push these, and that allows that extra pressure to discharge. Otherwise, you could find yourself in a bad situation. We've had customers that have not released that pressure, and they flip the tabs on these chambers to replace the quartz sleeve or the lamp, and it actually shoots this thing into the ceiling because there's so much pressure, and you certainly don't want that to happen. It's dangerous, and then of course you find yourself without water, and if you don't have an extra quartz sleeve or lamp on hand, then you've got to get one before you can start using it again. So again, this is a 16 to 20 or so gallon per minute system. These come in all different sizes. You can get them with the filter housings and cartridges. You can get them without, and then do them separately. These wall mount manifolds make it nice and easy because you just mount it to the wall, like I've got it here mounted to this metal beam, and you just plumb it in one side and out the other, and that saves you a lot of extra labor. But if you do want to do them separately, you certainly can buy all of these things individually and install them that way. Another thing I should mention about this particular pump, this is a CME Plus made by Grundfos. They also have one referred to as a CMBE which is their above ground constant pressure line. And these pumps actually have a pressure transducer or sensor on the back side of them that monitor the amount of pressure in the piping system. And that's what tells this drive that's on top of the pump to speed up or slow down. So the pump has not been in use since we've been standing here, but if someone were to turn water on somewhere, this pressure sensor would recognize a drop in pressure in the piping and would turn the pump on, and you'd hear it speed up and slow down, just like the one over against the wall that we looked at a while ago. So that's it for this point of the presentation, and I guess that's it for now.